I want to talk here about composition of functions. Now, if you've gotten this far in algebra, you probably have done a fair amount of composing functions. You just might not have called it composition. So let's start off with a really quick example. Let's say that we have f of x equals 3x squared minus 4x plus 2, and I asked you to find f of 0. Well, you probably remember from your previous sections in algebra that this means plug x equals 0 into f of x. So whatever is in the parentheses is what we're going to replace the x's with in our f of x. So this would look like, let's see, everywhere we have an x, I'm going to replace it with some parentheses, and then into those parentheses goes 0. So 3 times 0 squared minus 4 times 0 plus 2, and then when we simplify that, we get 2. Okay, let me do one that's a little bit more challenging, because hopefully you remember that one. Let's say I asked for f of a. Okay, so in f of a, we have everywhere we see an x, we're going to replace it with a. So into each one of these, instead of 3x squared, I have 3 parentheses squared, and instead of minus 4x, minus 4 parentheses, and I'm just going to replace where the x's used to be with a now. So I have 3a squared minus 4a plus 2, and there's not a lot of simplifying that happens here, so I'm going to rewrite this as 3a squared minus 4a plus 2, because none of those are like terms. Now let's say I made this a little bit more challenging. Let's say I made this f of x minus 2. Okay, so that would be everywhere I see an x in 3x squared minus 4x plus 2, I'm going to replace that with parentheses. So 3 parentheses squared minus 4 parentheses plus 2, and into those parentheses I'm now going to put that x minus 2 instead. So I have 3 times the quantity x minus 2 squared minus 4 times the quantity x minus 2 plus 2. And I'm going to simplify that in just a second, but what I want to point out is what we did. Anything that's inside the parentheses just simply is what we're going to replace our x's with. So if we have x minus 2 in the parentheses, we've got x minus 2 in place of all the x's. If we have a inside the parentheses, we have a in place of all the x's. So let me FOIL this out, because this is a little bit more algebra to simplify. This would be x minus 2 times x minus 2. I can distribute that 4 pretty quickly. Make negative 4x plus 8 plus 2. And I know you probably know how to FOIL and multiply. So this would be 3x squared minus 2x minus another one plus 4. And combining like terms on the outside, negative 4x plus 10 is, let's see, 3x squared. If it's okay with you, I'm going to do negative 2x, and negative 2x is negative 4x, times 3 is negative 12x. 3 times 4 is 12, minus 4x plus 10. So we have 3x squared, negative 12, negative 4 is negative 16x, and 12 plus 10 is 22. So the hard part of that problem was all the algebra in here, but the important part of that problem for this section is right here, where whatever is in the parentheses is getting put in the place of x. So if you're watching this video, you're probably wondering, I've already done this before. And that's absolutely true. I'm sure you've done this before in previous algebra sections. The only thing that's going to change here in this section is what we're calling the composition of functions. So let me rewrite that last part C in a slightly different way. There we go. So again, I have the same f of x is still 3x squared minus 4x plus 2. And if you look on the second line, this was what we had a minute ago. F of x minus 2 is, well, take the x minus 2 and plug it in place of the x's. So 3 times x minus 2 all squared minus 4 times the quantity x minus 2 plus 2. And here's what we got for our answer. 3x squared minus 16x plus 22. Now let's say I want to name the x minus 2. So the letter that comes after f is g, so let's name it g. So g of x is x minus 2. The way we're going to state the questions in this section is with the notation composition. So here's how we do that. We're going to write f, we need a new symbol, so open circle, of g of x. And what we say is f composed with g of x. And what that means is plug g of x into f of x in place of the x's. Take your g of x and plug it into f of x in place of all of the x's. So let's do this with another set of functions. Okay, so let's look at these three functions. F of x is equal to the square root of x minus 5. G of x is equal to 4x plus 2. And h of x is equal to 3 divided by x plus 1. So let's play around with this new composition operation. For the first one, let's do f composed with g of x. Okay, here's how I like to do these. I start with my first function, f of x. So f of x is the square root of x minus 5. And I write that function. Except everywhere I have an x, I replace it with parentheses. Now, remember what composition meant was take your second function and plug it into your first function in place of the x's. So if I've written out my first function with parentheses instead of x's, then I can take the second function, which is g, 4x plus 2, and put it into those parentheses. 4x plus 2. So saying that one more time, take the first function, write the first function replacing any x with parentheses instead. And what goes into those parentheses is whatever the second function is. Once I do that, now I just have some simplifying to do. Let's see, nothing gets distributed here. So this is simply going to turn into the square root of 4x minus 3. So f of g of x is the square root of 4x minus 3. Okay. Some of your problems might ask for f of g of 7. What that means to do is plug in x equals 7 to your composition. So in this case, it would be the square root of 4 times 7 minus 3, which is, oh, this works out nicely. The square root of 28 minus 3 is 25. And we get 5. So if you see a composition f of g of a number, That simply means to plug in, when you're done composing, whatever that number is with your x value. Okay, let's try another one. Let's do h composed with f of x. Lots of colors here. So I don't want you to get too distracted from the colors. So let's do that. Okay, remember what I said I did was start with my first function. In this case, first function is h. H of x is 3 over x plus 1. So I'm going to write 3 over parentheses plus 1. So everywhere I have an x in my first function, I'm going to replace it with some parentheses. And into those parentheses, I'm going to put the second function. So the second function here was the square root of x minus 5. Okay, so not a lot of simplifying to do here. So I have 3 over the square root of x minus 5 plus 1. So that is for h of f of x. And kind of like in this previous one, if I asked for h of f of 10, that would simply mean to plug in x equals 10 into h of f of x. So that would be 3 over the square root of 10 minus 5, and then plus 1, which would be 3 over the square root of 5 plus 1. Okay, let's try a couple more with these. So here, let's do g of h of x. Now, as you've been watching, order really matters. So starting with my first function g of x, which is 4x plus 2, I'm going to put 4 parentheses plus 2. And then into those parentheses, I'm going to put h, 3 over x plus 1. Not a lot of simplifying to do here, but I could change that 4 to a 4 over 1, so I can combine the 4 and the 3x plus 1 into 12 over x plus 1 plus 2. Okay. Last big point I want to make is you can compose a function with itself. So for f, let's do g of x. G composed with itself. Okay, well the game still is the same here, so I'm going to start with g, which is my first function, 4x plus 2, and I'm going to replace all of my x's with parentheses. And into those parentheses, I'm going to put the second function, which is also g, 4x plus 2. So I'm taking the second function and plugging it into the x's into the first function. And doing some simplifying, that's going to give me 16x plus 8. So 16x plus 10 when we add the 8 and the 2. Let's do just one more. Let's do f composed with itself of x. So starting with f, which is the square root of x minus 5. Give myself a little more room there. I'm going to plug in the second function, which happens to be the square root of x minus 5, and I don't have any simplifying to do here except maybe not writing in the parentheses. So I have the square root of x minus 5 minus 5. There's one more quick type of problem I'd like to show before finishing this video, and that is identifying a possible f of x and g of x for a given function that is equal to f composed with g of x. This will be a really helpful skill in calculus. So let's say for the first one that our h of x is given by the square root of 3x plus 2. Now there are truly an infinite number of possible responses to this, but just so you kind of get the hang of this, we're talking about nested functions, one function getting plugged into the other function. So one possibility might be that the inside function is 3x plus 2, and that the outer function it was plugged into, remember it got plugged into the entire x, so that would just be the square root of x. That would be one possibility. So you can check this really quickly by doing f of g of x here on your answer, and hopefully you get the square root of 3x plus 2. So looking really quickly here, we've got g, and we're going to plug it into f. So this is for our check. And f is the square root of x, so I'm going to make the square root of parentheses. And 3x plus 2 is what I plug in there. And sure enough, this is the square root of 3x plus 2, which is what we wanted. Let's try one more of these. Let's say h of x is equal to the absolute value of 2x minus 7. Now remember, I don't want one only answer. This is just one possibility. So one possibility could be let's see, looks like the inner function, 2x minus 7, looks like a pretty good start for the inside function, and the outside function that it gets plugged into, absolute value, well, that whole thing was x, so absolute value of x. Okay, so really quickly, let's check this. So f of g of x, start with your f, absolute value of some parentheses, because it was the absolute value of x, and plug in your g, 2x minus 7, and sure enough, again, we get the absolute value of 2x minus 7. So it is a valid possibility.